Hello aspirants, welcome to UPSC CSAT with Koshik. Today we are going to start a new chapter called SCF in NCF. Basically this chapter is a part of number system only. Number system itself is a big chapter where there are many small topics are there. For example, we can take it as a SCF LCM, fractions, number series and many more. The basic of number system we have covered. They are the supporting ones which are important also. Before starting today's lecture, I want to convey a message. Basically, students emailed me about the previous lecture that they are unable to complete the lecture in a time bound manner. Basically, the earlier previous one was 3 hours lecture, 3 hours 5-minute lecture. So the student face problem like they have to pause the video, pause the question, and then they try to attempt the question themselves, and then they play the video and get the solution from my end. And this is a very good approach they are following, and the length of 3 hours get to the 8 hours. That's the problem. So they are very much right on their behalf. Now what I am proposing that let's start with 1 hour 30-minute lecture from today onwards. And if you guys have any issues regarding the timing or the length, you can mention it in comment box or email me at csatwithkoshik@gmail.com. Okay, without wasting any further, let's start today's lecture. Let us start today's lecture, SCF and LCM. Before starting the lecture, we have to study the basics of the SCF and LCM, which is factors and the multiples. What are they? Factors are set of numbers which exactly divide the given number. Okay, for example, for timing, let's say we have a number called 8. Okay, so how many numbers are there which exactly divide the number? The number is 8. Okay, so let's do it. 2, 2 and 1. So what these elements are? These elements are basically called the factors. Let's write here. What are the factors? Factors are the basically those numbers which exactly divides the number itself. So let's start from the 1 itself, because 1 is like a god. It will be multiplied by anything, it will be divided by anything. 1. So 1 is there. Now take 2. Okay, now again you want to write 2. No, club them. 4, club them, it become 8. Any other formation is there? No. Everything is covered? Yes. So the factors of 8 is 1, 2, 4 and 8. Very well. Now what are the multiples? Set of numbers which are exactly divisible by the given number. Okay, given number is here is 8. Now we are talking about the multiples. It's a basic thing. What are the multiples? 8 into 1, 8. 8 into 2, 16. 8 into 3, 24. 8 into 4, 32, and so on. So these are the multiples. Basically what I want to show you is factors are the smaller units. in a number itself. This 8 is made up of smaller units of which it have 1, 2, 4 and 8. Okay, and multiple is, the number get multiplied with a number 1, 2 and many more. They are the multiples. Factors are the smaller components of a number in itself. Now let's move ahead. Factors of a number are always less than or equal to the given number. Obviously, if a factor for say more than 8, for example here it is 16, then factor will be, this will become a multiple, not a factor, because you can see here. So the first requirement of the factor is it should be equal or less than the number itself. Okay, multiple of number are always more than or equal to the given number. Yes, here if you put say sir it is, now what will you say? No, it become a factor because it goes below the 8. I hope you understand the basic concept of factors and the multiples. Now move ahead. Before starting the LCM, first you have to be clear on the what are the common multiples. A common multiple of two or more number is a number which is completely divisible by where it will not give you any remainder. Okay. Let's try to understand the statement with the help of example. Take a small numbers. Let's not take complicated in 3, 5 and 10. Okay. So we are talking about the common multiples. What are the common multiples of these numbers? Let's check. No need to solve them. It's for only for explanation. Don't solve them. Just observe the terms. 3, 6, 9, 12, 15, 18, 21, 24, 27, 33, 36 and so on. Now multiple of 5, 5, 10, 15, 25, 30, 35, 40 and so on. Multiple of 10, 10, 20, 30, 40 and so on. Now we have to find out the common multiples of these numbers. Okay, is 3 is there? No. 6 is there? No. 9 is there? No. 12 is there? No. 15 is there, but in the first two, not all of them. So we will not consider 15. Okay. 18 is there? No. 21, 24, 27, 30 is there. 30 is there in 3, in 5 and the 10. So the common multiple of 3, 5 and 10 is 30, but we have find. Now when we move ahead, there will be a 60 at 3 and here also 60. You can 45, 50, 55 and 60, and here also you have 60. This is also a common multiple and so on. Now the least common multiple is 30 here. 30 means there is no common multiple in front of 30 means 30 is the least. There is no 10, no 5, no 6, no 2. 30 is a number which can be divisible by all of these numbers. That's why it's called least common multiple. So let's understand what is the least common multiple. The least common multiple of two or more given numbers is the least number to be exactly divisible by each of them. Exactly divisible by each of them. Let's try to understand with another example. For example, we have taken here 3, 5 or 10. Let's take some 4 and 12. It's a good number. Begin multiple of 4, 8, 12, 15, 20, 24, 28, 32, 36. Now multiple of 12, 12, 24, 38, 60, 72 and so on. Okay. Now we are talking about the common multiple, but we have to find out the least one. Let's start. Obviously, there is a 4 and a 12, and we need a common multiple. So 4 is not going to be because we have to start with the 12 only. See, we have to start with the 12 only. Because if you take 4, 4 should not be here. 8 should not be here because we are talking about the multiple as we have studied there. If it goes below the number, then it becomes a factor, not a multiple. Now we are talking about the multiple, so it should be more than 8 now. It should be more than the number itself now. The same thing. So 4 is not there, 8 should be not there. So we do not want to waste our time in this. So it is the basic thing that if you have two numbers, then the LCM should be more than, should be the number, the greater number, or the number above the greater number. Here, do not waste your time in calculating 4 and 8. Start with the 12. Yes, 12 is there, the common multiple. Okay, now 24 is there. Now 36 is there. Now 4 is also divisible by 48. So there are many factors. Okay, and you can say that the yes 12, 4 is a factor of 12. So whatever multiply by 4, it will be a multiple of 12 also. So what we have understand by this demonstration that if a first number, if a number is a multiple of the second number and the first number is the lower one, then whatever the multiple of the first number, it will be the multiple of the second largest number also. For example, we say that here, if we break down this in a formation of 4, we can find that 4 into 3. Here we can find it 4 into 6. Here we can find it 4 into 8. Here we can find it, sorry, 4 into 9. Here we can find it 4 into 12 and so on. Means in each number there are 4. That's what I am trying to. Now, what are the least? Now we are talking about the least common factor. So the least common factor in these number are 12 only. So below this there are no such number found. Okay, let's move ahead. Now let's discuss the method to calculate the LCM. Basically, there are two ways to calculate the LCM. First is prime factorization method and second is division method. Start with the prime factorization method. It's always good to start with the example itself. It will help us to understand each step. Okay, take easiest one, any number, 8, 12, and 15. It's a good start. 8, 12, and 15. Basic numbers. Just start with them. So what step 1 says? Resolve the given number into their prime factors. Prime, What are the factors? As we have discussed earlier, that factors are the numbers represented in a very fragmented way. Okay, this format basically. Okay, and they are talking about the prime factors. Prime means which they means a number which divide by one and the number itself. So they want number to be break in the very shortest part. For example, let's take at it. Sorry. Now we need a prime, so try to divide them in a very short possible way. 2, 4, 2, and the 1. 1, if you want to write 1, you can, otherwise 1 plays no significant role here. So the way to write the number 8 in a prime factorized method is 2 into 2, 2. Okay, now how 12 can be written as 6, 3, and 1. Okay, so we have 2 into 2 into 3. No other prime factors are possible for now. Prime factor, I'm not talking about the factor. Factors are possible, but not prime factor. Prime factors mean the lowest term, lowest ways you can write that. The term prime is important here. You can make many factors, but prime is important. Now, for 15, the smallest one, na? 3 is smallest, 5. So you can write them in 3 into 5. Okay. Now, the step 2 is saying find the product of the all prime numbers with the highest powers that occur in the number. So find the product of all them means they want us to make a product of all the prime numbers which have the highest power. Let's simplify this. We have 2 into 2 into 2. Basically, 2 is repeating themselves in 3 times. Means we can write it as 2 to the power 3. Okay. In this case, we can write it as 2 to the power 4. Oh, sorry, 2 to the power 2. And this as 3 to the power 1. In this case, 3 to the power 1 and 5 to the power 1. Now, they want us to make the product. So, and the highest power only, and the highest power. For example, here we have 2 to the power 3. In this case, we have 2 to the power 2. We have to consider the highest power. Highest power here is the 2 to the power 3. So take the 2 to the power 3, discard 2 to the power 2. Now we have 3 to the power 1 and 3 to the power 1. Basically, 3 to the power 1, the only one factor we have available. So there is no comparison. So we have to write 3 to the power 1, write 3 to the power 1. And we have 5 to the power 1. There is no comparison because only one component is there. So we have to write it 5 to the power 1. Okay. Now this product of the all prime factors is equal to the algorithm. Basically, when you multiply all of them, then you will get the basic LCM of these numbers. 2 to the power 3 is basically 8. 8 into 5 is 40. 40 into 3 is 120. Answer is 120 here. I hope it is visible. So that's how you have to calculate the LCM by prime factorization method. Why it's called prime factorization method? You use the factors, the lowest possible factor, the number which is divisible by itself or the one. That number should be considered in this method. Okay, and then you have to make in a power format, use in a power format, and then take the power, maximum power component, and leave the other ones. Okay. For example, here we take the 2 to the power 3. Here there is equal at both sides, but there is no comparison, so we take the 3 to the power 1. And here 5 to the power 1. And there is no 5 in both of them. So we write the 5 to the power 1. If there is 7 also, we will write the 7 also. There is 11 also, we will write the 11 also. But in the power 1, if there is no commonality between them. For example, if it is 2 here, 3 to the power 2, then we will do 3 to the power 2 here. And again, if there is 2 here and here it is 5 here, then we will take the power 5 here. Okay. And similarly, if there is a 5 to the power 5 here, then we will take the 5 to the power 5. So we have to consider the highest possible power in the product. Okay. So that's how you take the LCM using the prime factorization method. Let's move to the next method. Sorry, my mic fell off. I didn't recognize it. Okay. Now we are talking about the division method. This method is similar to the prime factorization method only. Okay. The only difference is you shouldn't have to take care of the this part. This where you take the prime factorization, then convert them into the powers, then solve them. In this case, you have to, for example, let's take the same example 8, 12 and 15. In divisibility method, you have to take care of, like, no need to make separate. Okay, take a common 8, 12 and 15. Now go from the least one, 2, 4, 6, 15. Again take 2, 2, 3, 15. Now 2 is there, 3 is there, 15 is there, 3, 15. Now it become 5 and now it's become 1, 1, 1. Here what we have to do, that if a number is easily divisible by the minimum prime, means we are taking the least common now. So if a number is divisible by 2, then we will divide, otherwise we will put them in their original format. Okay, until the number will not divide them. Here, like 15 is divisible by 3, then we divide them and keep others like only. So this is a very simple formula. It's not a formula, it's a type to solve the LCM. Now multiply them. 5 into 3 into 2 into 2 into 2, 5 into 3, 15, 30, 60, 120, which is similar to the earlier one. Now let us take one more example, a bit complicated one. Not so complicated, but I want to give you a way to solve them much faster. Okay. For example, here 15, 24, 32 and 45 is there. Now again 15, 24, 32, 45. Start with the lowest one, which is 2. 15, 16, 45. Again 2. 15, 6, 45. Again 2. 15, 3, 4, 45. Now there is the lowest term is 3. Take 3 only. 3, 3 5s are 15, 1s are 4s are 3 1s are 3 5s are. Now the lowest term is 4. Put 4 here. Now 5. Now 3. So multiply them. 2 into 2 into 2 into 3 into 4 into 5 into 3. So that's how our divisible rule work. Now let us calculate them. We have 10. Now it's 20. Now 40. Now 40 into 120. Now 120 into 4, 480. And 480 into 3, 1440. So that's answer. Both the method have their unique properties. In coming questions, you will find that prime factorization method is play a very vital role, whereas to find LCM only, you can take this method, which is faster. So both the method have their own significance. Let's find out. Okay, now let's focus on the vectors. Till now we have discussed about the multiples. You can see that multiples, LCM, least common multiples. Here least common multiples, common multiples. Now we are going to study the factors. Again I am trying to emphasize on the basic concept so that you can, you know, you learn the concept and don't intermix them. We have studied this part. Now we are focusing on factors. In factors, the maximum number is the number itself. For example, 8 here, and the other number will be lesser than 8. Now let's start. Common factors. A common factor of two or more numbers is that particular number which divide each of them exactly. Okay, it is basically it is similar to the multiple only, but there are few differences. Please pay attention. Let's start with the example. For example, we have to take common factors of 48, 54, and take some odd one, 63. Okay, so please tell me the factors of 12. In above question, we have talked about the multiples. Okay, multiple. Now we are focusing on the factor part. Factors of 12. The maximum we can get is the number itself. So 12 is here. Then 6 will be there. Then 4 3 is 12. Then 6 2 is 12. And then 1. Okay. How I write? Basically, you can do this also. It is 12, then 2 6 2 3 3 1. Okay, so how many factors are there? 1 is there, 1 is there, 2 is there, 2 is there, 2 into 2 4, 4 is there, 4 is there, 3 is there, 3 is there, 4 into 3 12 is there, 3 into 2 6 is there. That's how you have to mention them. If you have no clear yet, then again let's take another example. 48. Example are the easiest way to learn something. Okay, now again we are talking about the 48. Now 48 should be there because the number itself be a factor. Now what is the common one? 24. 24 into 2 is 48, so write 2 here. I am trying to solve in a very easiest way. 48 into 1 48, 24 into 2 48. Now 16 into 3, 16 into 3 is possible. Yes sir. Now 12, 12 into 4. Yes sir. 5 is possible. No. 6 is possible. Yes sir. 6 8. So these are the factors. Sorry, this goes to this, this goes to this, and this goes to this. That's how thing works. Now let's again attempt of 54. Now for the 54, 54 into 1. Okay ji. Now if we put 2 here, then what we have? 27. Okay. Now if we put 3 here, what we have? 3 ones are 3. Okay. Now if we put 4 here, no, 4 is not compatible. 6. Yes, 6 into 9. Or if we put 7 here, is that there? No. Any other? No. So these are the factors. You can solve it like this also if you want to. Otherwise, just try to multiply them, you will get the answer. And what we have now? Factors of 63. Of 63. Factor of 63 now. 63 into 1. Now if you put 2, you will never get a odd. 3. Yes, 3 is possible. 21. Now 4 is not possible. 5 is not possible. 6 is not possible. 7 is possible. Yes. 7 is possible. 8 is not possible. 9. 9 is there only. Okay. So the factors is this one only. Is there any kind of difficulty? I don't think so. Now we want to find out the common factor. Common factor are those factors which are repeated in all of them. Now let us find out. 12. We have 12 here. We have 12 here. We don't have 12 here. We don't have 12 here. So 12 is not a common factor. We have 6 here. We have 6 here. We have 6 here. We don't have a 6 here. So 6 is also not a common factor. Okay, ji. 4 is there. 4 is there. 4 is not here. 4 is not here. 4 is not common. 3 is there. 3 is there. 3 is there. 3 is also there. So 3 is the common factor. 2 is there. 2 is there. 2 is there. 2 is not in all of them. So 2 is not. And don't consider the 1. Now 3 is the common factor of 3 is the common factor of 12, 48, 54 and that's how you have to find out the factors. Okay. Now let's focus on the highest common factor. There may be chance that you have multiple factors in them. For example, for just for a just for sake of example, let us not consider 63. Okay, just for a time being. Now we have how many common? We have 3 in common, we have 2 in common, we have 4. No, 4 is not common. 6 is common. Yes, 6 is common. And we have 12 in common. So which one? 12 is common? No, 12 is not common. So now which one is the highest common? Highest common, basically 6 is the highest common. That's how you have to find out. Okay, now we will discuss in the definition itself. We will discuss here. Let me make it. Okay, now highest common factors. So what are the highest common factor? Highest common factors of two or more number is the greatest number which divide each of them exactly as we have discussed. It is also known as highest common divisor or greatest common measure. Okay, please remember the basic terminologies. These terminologies can be used in your examination and you guys get puzzled when these kind of terminology used. You will think like, okay, I do not have any idea about the question, let's leave it. But basically they are asking about the highest common factors only. Now we have basic clarity about highest common factor as we have seen here. Okay, so I don't think we need any other example. Now focus on the methods to calculate HCF. Okay, there is also two method, prime factorization and the division method. Where is it? Similar to the multiple method, this one, as we have attempted. If you guys didn't understand this method, it's kind of revision only. Okay, factor is here, common factor we have decided. Now what are the prime factorization method? This is clear that whatever the number is, we have to make things separately. Then we have to take the power format and then we will compare and multiply. Okay ji, let's take an example first. Take a easy one, 24, take 30 and 42. It's a very easy one. Okay, now try to do this like this, 30 and 42. Okay, now you have 2 12, 2 6, 2 3 3 1, 2 15 3 5 5 1. Now 2 21 3 7 or 7 1. Okay, now you have all the minor factors of each of them. Please write them in the power format. Basically they are 2 into 2 into 2 into 3. This is 2 into 3 into 5. This is 2 into 3 into 7. We can write this in power format like this: 2 to the power 3 into 3 to the power 1. And they are a singles, so you can write it 2 into power 2's power 1, 3's power 1, 5's power 1. And this also 2 power 1, 3's power 1, and the 7 powers 1. Now in the multiple we have, where it is multiple, yeah, here. Please pay attention, please pay attention. In the case of multiplication, what we have done is take the higher number in each of them. If the number is higher, for example 2 to the power 3 is here and here is 2 to the power 2, you have to take the 2 to the power 3 and discard this one, na? And then if 3 is there, single component, take them. Here we take 3 and 5 also. Now the only difference here is, please try to focus and try to take out the commonalities only. Commonalities means here 2 to the power 3, here 2 to the power 1, here 2 to the power 1. In all of three, there 2 to the power 1 is common. 2 to the power 1 is common. You can write 2 to the power 3 is like 2 to the power 1 into 2 to the power 2, because power get added in case of multiplication. So we have 2 to the power 1 common in all of them. Okay ji. Now what is the purpose, sir? Because we are trying to find out the highest common factor. Highest common factor. Okay. Now we have 2 to the power 1. Here if we take out 3 to the power 1, 3 to the power 1, 3 to the power 1. Okay ji. Let's write down 3 to the power 1. Now do you have any other? No, 5 is there only, not here. So how it can be the common? It's not common. So leave that. 7 is there? No, 7 is not here. 7 is not here. So do not take the 7. Now multiply them. You will get 6. 6 will be the highest common factor of these three terms. Okay ji. Now let us focus on the division method. This is also a similar method. Now okay, let's read this first. These are the similar, but note is important, that's why here it's mentioned. What note said? To calculate the highest common factor of more than two numbers, calculate the highest common factor of first two numbers and then take them. See, in the earlier one we just compare them, okay, but in highest common factor the process is you have to solve first two, then you have to move on the third one. Don't just jump on the, compare all three. Don't do this. Try to solve first two, then whatever you get from there, then compare with the third one. That's the statement means. We will do the example, then you will get the clarity. And what the second says, to find the highest common factor of given number, you can divide the number by the lowest possible differences. Yes, If these numbers are divisible by these differences, then this difference itself is the SCF of the given number. Otherwise, any other factor of this difference will be its SCF. I am so sorry. It's late, but have to record. Let's start this with an example. First, with the simplest one. Uh, let's take example, a simple one. 26 and 455. Why, sir, you are taking the two numbers? Because according to this, we have to take the two numbers first, then move to the third one. So for the time being, we are taking the two numbers. Okay. Then we will move to the three numbers. Then we will move to the other or. I just want to show you how SCF works. Okay, ji. In the division method. Now, what division method says? Please pay attention. This is bit complicated. 26. Okay, we have to find out the highest common factor. Now, 26 ones are 26. Okay, what comes? 9 and 1. Okay, now sevens are 182. Now, what you have? The remainder one is 13. 13. Now, 13 comes here and this part comes here. 26 here. Now, 26 comes here, at the 2 it goes out. So the highest common factor is, in this case, is 13, which become a common between the two subjects. Which are the two subjects? This one and the this one. Okay, let's do the second. Let's take a second example for better understanding. Example 1. Let's take example 2. In example 2, take three number for the time sake. We need a paper. Okay, we have one. Example 3. This time we will take a big number. Let's take, okay. Now, according to this, we have to take the two numbers. Okay, we will do that. We will take the two numbers. Now, we have 210. Put the value here. Okay, 1785. Now it goes to 200 into 8 in 1600, so around 8 it will be. So 0 8 and it's 16. Okay, yes, after that it become in 1800 range or a 1900 range. So 0 1. Now again it's short. Now put this value here. Okay, 210. Now add 2, it goes, it is cancelled. So for these two, which two? For these two, the highest common factor is 105. 105, because at 105 the remainder goes to nil. So 105 is the common factor of these two. Okay, ji. Now what the note said is, then take the third number and SCF of the first two number, calculate their SCF. Okay, ji, as you say. Now what we have? We have 3381. Now this become a number. See, we have solved this and we get 105. 105 as a result. Now we have to focus on the these two part, 105 and the 3381. Okay, let us see. We have 105 and 3381. Now threes are obviously three is there, so threes are say threes are 315, 321, and twos are okay, twos are is 21. Now this become a shorter one. Now put this value, which value, this value here. Okay ji, let's do it. 105. Now at 5 this get fully divided, so the highest common factor in this case is 21. Now the highest common factor of all the three are 21. Okay, for all of these it become a 21. Please try to understand the concept. Okay, first solve these two, then whatever the LCM you get, for example x, then take these two, and whatever the value you get, that become the highest common highest common factor. I hope you guys understand. Let's move to the next one. Now let us try to understand the second note. I just copied that and paste it. We are doing this one only. Okay, for the you know ease of doing business, I just write it there only. Now what the statement means note 2 says, basically it's note. To find the SCF of given number, you can divide the number by their lowest possible difference. It will be always good to start with the example only. Let's take an example with very easy numbers so that we will solve them easily, and take one big one. Okay, now what the first line of the note says, to find the SCF of given number, you can divide the number by their lowest possible differences. First of all, which of the following will have the lowest possible difference? Obviously 30 and the 42. For example, if you take the difference of 30 and the 135, it will be 104. And if you take the difference between 42 and the 35, it is also a very big. So the only possibility which have a smallest possible difference is the 30 and the 42, which gives you 12. Now what second line says, if these number are divisible by this difference, then this difference itself is SCF of the given number, otherwise any other factor of this difference will be its SCF. Now 12 is R12 is divisible by 30. Yes or no? No. Okay. Now 12 is divisible by 42. No. Is 12 is divisible by 135? The answer again is no. So 12 is not going to be a factor. Okay. But is there any factor exist in 12 itself? Yes, sir. Bilkul. 12, 1, 2, 6, 3, and 4. Is there any other? No. Not at all. Now, try to understand one thing. Is 12 is going to divide? No. If it is going to be divide, then the answer is 12 only. Okay. Is 3 is able to divide them all? See, 6 5s are, and 6 sevens are 6 to the 12, and no, 6 is not able to divide this one. Okay ji. Now take the 4. 4 will not divide the odd number. Okay ji. Let's take 3. Yes, yes, yes. So 3 is the HCF of all three numbers. For better understanding, I will repeat myself. What this statement says, don't fall in the statement. Try to understand. If you have three numbers, okay, first step is try to compare them with respect to their differences. Take the lowest possible difference. In this case, this is possible. The difference is 12 itself. Then try to check, is the difference, which is 12, is going to divide all the three number or not. If the answer came yes, if the difference is dividing all of these, then the HCF is the difference only. If answer comes no, which is come in this case, then try to make factors, which we have done here. We make the factor and then try to divide these digits. In this case, 12 is not able to divide them. Okay, 6 is not able to divide them. 4 is not. But 3 is dividing all the 3. So the 3 become the answer. I hope you understand this note also. This is a very good note, and this is basically a trick to find the SCF in a faster way. Let's move ahead. Now this is very important part of the chapter. Here in examination they will give you some fractions. Okay, there are some numerators and there are some denominators. Okay, now they ask that please find the LCM or HCF of these fractions. When this question came in the examination, do one thing. Take, if you are going to calculate the LCM, always take care that at numerator try to keep what the question is asking. For example, in question, the demand of the question asks, please solve the LCM of the fractions. Then take the LCM on the numerator part. Okay, LCM of numerator. Numerator are basically the number which is above on the fraction. Okay, so take the LCM of the numerator and HCF of the denominator. Denominator are the lower part of the fraction. Now, if they ask, please find out the HCF of the of these fraction, then do the same. Keep the above with the numerator only, HCF of the numerator and LCM of the denominator. I hope this is very much clear for you. Okay. Now there are some important aspects which you have to take care of. All the fractions must be in the lowest term. What the meaning of the lowest term here? See, the number, for example, let us say there is a number called 8 by 16. These fractions are there. Now, no need to solve this. For example, there are some numbers 6 by 12, 18 by 48, 13 by 39, 4 by 48, 9 by 81. Okay, and you have to find out the LCM of these fractions. Now the first requirement is these number should not be in their highest form. They should be in the lowest possible formation, but in the fraction only. For example, you have to cut them, try to reduce them, short them. Okay, now now these number are in the shortest possible numbers. Okay, now you can take LCM or SCF, whatever they are asking in the question. Now take the LCM or SCF of these numbers. Now let's read the second note. Now note 2 and note 3 are obvious ones. How? Let's read. The required SCF of two or more fraction is the highest common factor, highest fraction, which exactly divide each of the fractions. This is all similar to the LCM also. The required LCM of two or more fraction is least fraction, which is exactly divisible by each of them. This is a very obvious one. I think there is no need to explanation, self-explanatory. Now in note 4, the HCF of numbers of fraction is always a fraction. In case of HCF, the fraction, if you are finding the HCF of any fraction, then the fraction, the answer will come always in the fraction only. Why? Let's try to find out. You have seen that mostly the HCF is very small, means for example let us take good example, 8 plus 8 by 9, 11 by 13 and 17 by 19. If this kind of situation emerges, there is very high chances that the highest common factor of these number will be very small. Okay, but when you take the LCM of the denominator, it should be bigger than the HCF. Now in this case, when you have a HCF in a shorter way, this will always give you a number with a fraction. Are you able to understand that? It will always give you a number in decimal or in fraction. You can solve this, you will get the answer. Or take any example, you will always find that if you are taking HCF of a number, then the numerator will always be short, but the denominator will always be the bigger. Okay, now this same concept will not be applicable on the LCM. For instance, if the number, because in generally LCM is bigger than the HCF. Now at numerator, because we are taking now the LCM, numerator have the higher digits and denominator have the lower digit. Now there will be a chance that the number get divided completely, or the number will always be greater than the 1. because LCM is bigger than the HCF. You have two terms with respect to the denominator. So, and they could be or might be equal also. For example, the LCM came equal to the HCF only, and they divided and give you 1, which means they are equal. So the note 4 says that the HCF of the number of fraction is always a fraction, but this is not a case of LCM. Now let us practice some examples what we have discussed in the notes only. Okay, I will take some good examples so that you guys able to understand whatever we have discussed till now. Please be patient and see. Okay, so what we have to calculate LCM. Calculate LCM. In next one we will do the HCF. Calculate LCM. Now what we have studied, that if you want to calculate the LCM, you have to take the LCM of the numerator and HCF of the denominator. Okay ji. Now let's take the LCM of the above numerator, which is 72, 126, 162. Okay, but but don't just start to calculate this in this formation, because as we have read in the note 1, I guess the note 1 says these should be at the least possible number. Okay, means try to cut whatever they can. For example, 72 by 250, cut them, it will be 36. 125, are there any 3? No, it will be not. 126 by 75, it will be, yes, 175. 3 4 the 3 2 the 3 2 the 3 5 the. Now is there any possibility? No. 162, 165, let us try. It will be 3 5 the 3. Yes, it is going. Okay, 3 5 the 3 5 the. Okay, now take the calculate the numerators. Okay, we are taking the LCM. Now take the numerator of 36, 42 and 54. 36, 42, 54 LCM, and a denominator 125, 25, 55, denominator, oh sorry, HC and F. Now let's do this. So the LCM will come okay, and at denominator what will the woman? 5. So for this number the fraction will be 756 by 5. You can solve these numbers. Okay, you can solve these numbers, practice these numbers, because they will act as a examples for you, and these are the solution for that. Okay, if I want to calculate them, I will show how I calculate, but you will not practice them. That's the only reason I directly solve this. This will be the answer. Try to solve them. You have enough material now to solve them. Okay, now let us take a one more example in case of HCF. Okay, take Now we will take one mix fraction, so that I can teach you how can solve the mixed fraction. If someone do not know how to, this is called a mixed fraction. This is a mixed fraction. Okay. Yes. So now we need to calculate the HCF of these numbers. Now 36 by 51, and in this case, please pay attention. If you do not know, you have to multiply this. Okay. Whatever the number comes, add with this. For example, what I am saying is 3 into 17 plus 9, and keep the denominator whatever it is. So first you have to multiply these two, then add the outcome with the 9 and keep the denominator same. Now if we have to calculate them, this will come as 60, yes, 60, yes, 51, yes, 60 by 17. So the number became 60 by 17. Now this is a good thing. Why I am telling the good thing? See, now we have to calculate the HCF of these two numbers. Good. So we have to calculate the HCF. So we have to take the HCF of the numerator and LCM of the denominator. Yes. LCM of the denominator. Now do that. I will do directly. Wait. If they are, see, always take care of the note 1. What I saw, they will be further divided. 3 1 3 3 2 6, 3 1 3 3 7. Now this become a very good this become a very good question. 17 and 17 things get very easy for me, and 12 and 60. 12, correct. So the highest common factor here is 12. If you want, if you see, please do it yourself. For the knowledge enhancement, I am just telling you how I am solving it. Please try to pause and do it yourself. Practice as much as you can. See, there is 12 and it is 60. I knew that 12 into 1 is 12, but 12 into 5 is 60, and the highest common factor in both of them are 12 only. So I write down here, and here is 17. Both are the least common. So the LCM will be the 17 only. This will be your answer. So please practice, and always take care of the note 1. Note 1 where all fraction must be in their lowest format. Okay. Please pay attention to these details. Let us move ahead. I guess there will be no confusion left. Now let us see some important concepts. And these concepts are very important for your examination point of view. Sometimes you can find direct questions in your examination from these concepts only. I tried to take a question on each concept. Here C1 stands for the concept 1, and this is not a minus, this states for like this, it's a direction. Okay, now let's start. Concept 1 states that if you have to find out the product of two numbers, then they are always equal to the highest common factor of that number, means these number, and the LCM of these numbers. Let's try to solve a question with the help of this concept. Question says the LCM of two numbers is this and their SCF is this. If the first number is this, then find the second number. According to concept 1, this is the product of two numbers is equal to the SCF of these two numbers into the LCM of these two numbers. Okay. In this case, we have number 1 is 189. We do not know about the Y part. Now HCF is 27 here and LCM is 2079. Now one thing is clear that this is divisible by 9. So the one of these is also divisible by 9. That's how it become multiple of y, because 9 should be there na. If one 9 is there, then there should be one 9 here or here. Let us try to find out. 9 twos are 9 ones are 9 threes are 3 ones are 3 sevens are. Now this number is surely going to divide by the 7. 7 twos are 14, 67, 7 twos are 14. Now what we have? 67. Now on 9, 63. Then you have left with the 49 and 7. So y is 297. See, why I explain this minor calculation, the reason behind that is we waste our time in writing steps. For example, I hope here it is visible. Okay, what I want to tell you is there is no need to write each values, like don't go with the steps. Some of you have habit of writing each and every detail of the question. Don't unnecessarily increase the steps. Then you will divide like this. Then whatever comes here, then you divide with this. And then write like this. No. Don't waste your time. Calculate there only. Okay. Time is very crucial in competitive examination. So develop a habit to solve this here only. When you have developed this kind of habit, then I am taking like you guys practice and a point come where you need not to write all of this. You will cut from here only. If you can pay attention to these three, you no need to write anything. You just cut from here. See, it is visible. Yes, it is visible. And like this 7, this, and the answer come khatam. So this the time to write this also get saved, but it's a very advanced one. I am not saying that start practicing in the question only, but try to save time. Okay, in these kind of calculation, these are the very easy questions. I hope you understand the crux of the question. Now let us move to the next one. This is the UPSC's favorite type of question. Okay, this concept is most important. Most important. Why I'm saying this? Almost every year, a question comes from this concept only, and this is very easy one. Directly or indirectly, the question comes from here. What concept says the greatest number we divide the number x, y, and z leaves remainder a, b, and c respectively is given SCF of this. Basically, what they are saying is if a situation arises where they take means there is a number, let us solve with the question only, it will help you. For question says find the greatest number we divide these numbers leaving remainder this respectively. We have to find out the greatest number. Okay, I hope you have understanding now what you have to do when they are asking about the greatest number. Greatest number means highest common factor. Greatest number, greatest possible number, highest common factor. They are asking about the SCF. Now what this is we have to find out the greatest number which divide these three numbers and give these remainder respectively. Okay, now if we remove the remainder from the digits itself, they get fully divided and that become very easy for us to calculate. Let's do it. When a number divide 29, it gives a remainder 5. Let's remove the remainder first. What 24 we have means the number should divide 24 completely. Now 60 have 12 extra, so 60 minus 12 it give you 48. Okay, and now 103 minus 7, this will give you 96. In this case scenario, I am seeing a common multiple here is 24. How? It is basically 24 into 1, 24 into 2, and 24 into 4. And the highest common factor here is 24. So the HCF, or basically they are asking greatest best possible number is 24 only. Or if they are asking you the highest common factor, then the same answer will come. I hope this concept is also clear, and this is the most important one. If you are not able to understand, then please repeat this concept. This is very important. Mark my word, you will find this in your examination. Let's move to the concept number 3. Now this one is very much similar to the concept number 2, but don't get confused here. Please pay attention. There are some few minor changes in this concept. Please pay attention. Concept third says the least number which when divided by x, y, and z leaves remainder a, b, and c respectively. First of all, we are talking about the least number here. In concept number 2, we are talking about the greatest number. Now is given by LCM. Because we are talking about the least, and there is a least LCM. But one thing you have to pay attention that LCM, they take the LCM of the number but minus the remainder uh, with a common remainder which is k. Let us see what is the where k is x minus a, which should be equal to y minus b, which should equal to z minus c. This formula is true for any number. Basically what you have to keep in mind that whatever the remainder, it should always same. For example, when you minus these two terms, whatever the remainder come, for example alpha, this alpha should be equal to the difference of y minus b, which is beta, and that beta should also equal to the when you minus z minus c to gamma. Okay, now these three, the difference of the three should be equal. Okay, now let us see here. Let's try to attempt the question. Find the least number which when divided by these three numbers leave remainders these three. Now they are asking about the least. Okay, so one thing is clear, we have to calculate the LCM. I hope this is clear. Now don't do mistake directly minus them and then put here, put here, put here. No, don't do this mistake. First check that is that condition is going to be fulfilled or not. Otherwise, if the condition is not fulfilled, this is not possible to solve via this method. Okay, so 24 minus 19 is 5, 32 minus 27 is 5, and 31 minus 36 is 5. So the condition is fulfilled that if you minus 24 minus 19, it will give you 5, and 32 minus 27, it will give you 5, and 36 minus 31, it will also give you 5. So the condition is fulfilled, all are equal. Now let's solve them. According to question, we have to take the LCM of all three numbers. All three numbers, not the this numbers. No, these are the differences which we have checked. The LCM original are the x is 24 here, y is 32 here, z is 36 here. You have to take the LCM of these three numbers. Okay, now let us take it. 24, 32, 36. In least common, try to take from the lowest possible only. Here I will start with the 12, 18, 6, 8, 9. Then again take 2, 3, 4, 9. Then again see 1, 4, 3. Now calculate them, multiply them. 288. So this number shows the this condition only, whereas we have a common difference of k in the value of 5 here. Now we have LCM of these three number, which is 288. Now we have to minus k, which is 5. So the answer will be 283 only. I guess it is good. Yes, it is good. The answer is 283 here. This is bit different from the concept number 2. Please pay attention, and I hope this is clear. Let's move to the next one. Now let us see the concept number 4. In concept number 4, this is the least number which when divided by x, y and z leaves the remainder k in each case. Okay, this concept is similar to the concept number 3 itself. In concept number 3, what we have done, that we subtract the remainder from the number itself, and then we check that are the remainder comes after the subtraction are common or not. If they are common, then what we do, we take the LCM and subtract the extra one. Okay, now in this case they are giving you remainder as a common. You can read this remainder k in each case. Leave the remainder k in each case means the remainder is the common itself. So this step get cancelled. And how you can know about this? Yeah, we do not You have to find this because they will give you a common remainder, basic sense. Now let's do this concept with question. Find the least number which when divided by 24, 30 and 54 leaves 5 as remainder in each case. Now 5 is a common remainder in them. Okay, and they are asking us find the least number when divided by these leaves remainder 5. So if we use the number by using LCM, we have the number which is completely divisible by these number. But we have to know about the number which always give the remainder 5. So in that case, we have to add 5 in the LCM to have that number, because when we solve the LCM of these three, the number get divisible by themselves only and no remainder will come. To get the remainder 5, we have to add 5 in it, 5 in the number, this number. Now enough talking, let's do it. So we are talking about the 24, 30 and 54. Take the LCM. 9. I don't think there is any more. Okay, let's calculate. So the LCM is 1080. Is this the answer? No, because we need 5 remainder na, and this will get divisible by all these things because these are the LCM only. So we have to add 5 to get the desired number. So the answer will be 1085. I hope the concept is clear. Let's move to the next concept. Now concept 5. Concept 5 says the greatest number that will divide x, y and z, or whatever they are, or how many they are, leaving the same remainder in each case. One thing is clear, they are asking about the greatest number. When you see the greatest number, this is sure that you have to take the highest common factor. Now what they are saying, that greatest number will divide this number, these three numbers, or any numbers, but the condition is they should remain, they should give the same remainder. Okay ji. When this situation arises, you have to calculate the common remainder in all of them. Let's try to find out. For that you have to take the SCF first of all, because there is SCF. So is this important to calculate the SCF of these three numbers? Yes or no? No, because we have discussed in above that we have to calculate the SCF of the difference of this number. You can go from the start and you have that note. Now let's try to solve this. What is the greatest number that will divide 99, 123 and 183, leaving the same remainder in each case, and also find the remainder? Okay, no issues at all. Now no need to take the LCF, oh sorry, SCF of these three numbers. Don't. You have to take the SCF of 99 minus 123, 123 minus 183, and 99 minus 183. Now if you do the question without modulus, modulus is what? Modulus is, for example, if we do the general subtraction here, we have minus 24. In this case we have minus 60, and in this case we have minus 84. But when we put the modulus here, the negative sign will go. There is no impact of sign in the modulus itself. That is why here they use the modulus. Please appreciate the lecture if you enjoy. Thank you very much. It's a humble request because no one is going to teach you the modulus. Let's leave. Now you have to calculate the HCF of these three numbers. Let's do it. 24, 60, 84. Only take the common first. 1, 2, 30, 4, 2. Again 2. This become this, and this become, sorry, 21. Now I do the 3. Okay, 3, 2, 3, 5, 3, 7. Now nothing is common. Leave. These are the highest common factors. What are they? 2 into 2 into 3. So the number come 16. Oh, sorry, 4, 12, 16. I am writing 16. Now number comes 12. Now they are asking about the find the common remainder. Find the common remainder. Common remainder of what? Common remainder of what? Common remainder of these three. When you divide the greatest number, which we have find out, which is 12, we have to find out the common number. The greatest number is 12. We have find out it. Now let us divide 99 divided by 12. And what was the second? 123. 123 divided by 12. And what was the other one? 183 divided by 12. Let's do it. Now it will give you a mixed fraction if you do like this. Okay, but when you do the full like this only, let us give you like this, then you will get the clear picture. Otherwise in this method you will get the mixed fraction. We will discuss the mixed fraction in next lecture, means in upcoming lectures we will do that. Now 12 8s are 16, and we will have the remainder 3. 12 10s are 120, and it will give the remainder 3. 12, so no need to calculate all of them because they have the same remainder, but just for your sake it will be 160, oh sorry, 180 here, and you will get the 3. So this is how you have to solve this question. The common remainder is 3. Common remainder is 3. I hope this concept is clear, and you will find this kind of question in your examination. So please pay attention to this kind of explanation. Let's move to the next one. Now let us discuss the last concept of today's lecture. There are some concepts left, but we will do it in next lecture. And this concept is one of the difficult one. Why I'm saying this is a difficult one? Because you have to mug up some key results. Why? If you solve them in examination, it will cost you much time, and there is a very high chance that if you stuck at some point, they will shatter your motivation to do that question. Plus the time involved in solving these kind of question is very high, so there is no point to solve in the detail. try to learn few key concepts. These kind of concept will help you in your examination. It will save your time. Okay, and there is very high chance to have these kind of question in your examination, because UPSC is asking questions from the concept only. You guys get surprised why we are not able to solve these questions, because you are not working on the key concept, you are working on the usual concept in your uh, coachings and whatever they are. So try to learn things, try to understand things. These are very vital concepts. That's why I mentioned C1, C2, C3, C4, C5, C6. They are concepts, they are very much important concepts. Try to understand why I am emphasizing on this. You will probably not get this kind of material in YouTube or anywhere else. If you find, then share with me. I will also subscribe and like their videos, because appreciation is very important. Appreciation is very important, and that motivates a teacher or a creator. If someone else is also working on their content and providing you a good, there's no, you know, why we have to be a competition. We will, no, we will like them, subscribe them, share with your friends. It will help you. Okay, so let's focus on the concept number 6. Let's understand this concept with the help of question only, because there is no purpose to read this. You will get confused in the explanation only. Let's start with the question, and then we will understand each of the element of this statement. Let's start with the question. Question says there are five numbers. There are five numbers. Five numbers. What are their numbers? I have no idea. Question says there are five numbers. Five numbers can be A, B, C, D, and E. Okay, five numbers. So in this case, we will take number given numbers A. Let leave it five numbers. You will get confused. Let's try to keep things simple. SCF of each possible pair is 4. Now SCF is given. SCF is given for each pair is 4. Okay, no issue, sir. LCM of all these five numbers is 27720. Okay. Now the demand of the question is what will be the product of all five numbers. No issue, sir. We have read that ki SCF into LCM, and you will have the product of numbers. In that case, there are two numbers x and y, but here we have five. No issues, no issue at all. Concept will be there, that only. But the one thing is changed is that SCF is 4. You SCF into LCM. This is the concept, na? No. SCF is 4. But in the five number, the concept here is n minus 1. N minus 1. Concept is n minus. So 5 minus 1. N minus 1. 5 minus 1. Why 5 minus 1? 5 are the numbers are 5s. A, B, C, D, N. So n minus 1, 5 minus 1. That you have to learn. Rest are easy. Now multiply the LCM. 27720. Now solve this. It will give you 4 to the power 4 and 27720. Now multiply this. 4 to the power 4, 256. If you do not know, then you will write it like this: 16 into 16. Then you will, easily calculate. Okay. you must know the 16 square. It is very much important. Now few students going to multiply them. No, try to use the unit digit method. 0 is there, so the last digit should be 0. If all the option has last digit 0, then no problem. Use this. 6 into 2, 12. The last digit should be 2 only. If all of them have the same, then you have a very bad luck and you have to calculate all. Okay, otherwise you will find out the answer here only. Okay, let's do the calculation. 7096320. So this is the answer, but no need to solve. I am trying to say that this much is enough. This much is enough. Okay, but if you have a very bad day, then you have to calculate it. So let's wrap this lecture here only. I hope all the 6 concepts are clear. If you have found any kind of problem, please email me, mention in comment. Okay, email ID is csatwithkoshik@gmail.com. Join the Telegram channel. You have all the PDFs there only. No need to make some notes. Sometimes uh, in 1 or 2 lectures there is some issues in saving the file and I lost the PDF also. In that case, I will give you the raw format of the PDF. Then you fill and use that for your future purposes. Rest I will try. I am trying to give you whatever possible. Okay. So hope you enjoy the lecture and try to revise as much as possible. We will meet you in the next session where we will complete. We will try to complete. We will try to complete the chapter in great detail. Let's wrap it up. Okay, thank you very much. Have a great day. Please do like, share and subscribe. Thank you.